Good afternoon. My name is Cherie Scott, and I will be presenting today with my colleague Jackie Batchelor on how we have used the power of FME to manage data in the recent flood that hit the east coast of Australia and devastated the area of Tweed local government. To give you some context, the February 2022 flood was one of the biggest flood events recorded in the history of Tweed. The Tweed River in Murwillumbah peaked at 6.5 metres, 200 mils higher than that of 2017. Murwillumbah narrowly escaped more widespread flooding as the CBD levee only overtopped at a few locations and for a limited time. The small township of Tumbolgum was one of the hardest hit areas, with the river peaking at 4.8 metres, more than 800 mils higher than in 2017. Houses and businesses were inundated, with outer areas of the Shire isolated due to the flooding, landslips and significant road damage. As the impact of the flood started to unravel, there were key areas we needed to focus on to provide to staff to be able to support the recovery effort. We needed to provide flood management teams with information around isolated areas cut off by flooding, areas where support is most needed by the community, coordination of waste and cleanup options. We also needed to provide managers and engineers with data to help them assess damage to council assets, damage to roads and infrastructure, and damage to wastewater networks. On top of this, we needed to keep the executive management and councillors up to date with statistics about the degree and extent of damage across the local government area. There were many challenges associated with receiving various data sets and running the required analysis and providing different outputs to staff and management. A couple that we will cover off on today, including data captured by external agencies and issues with location accuracy, the use of free-form inputs of addresses and free-form input of attributes. Data provided in inconsistent formats, Excel spreadsheets that had messy input and structure, images embedded into Excel spreadsheets, and again, free-form inputs of attributes. We also needed to be able to have quick and efficient capture of asset condition, to be able to give condition reporting on council-owned assets and identify safety issues, to be able to be used in the field by non-trained staff, and fast reporting back to managers.
Daily data was provided by the SES via the Emergency Information Coordination Unit, which was capturing the initial damage assessment of properties. This data was sent as a point shapefile location of the property, which recorded the extent of the damage and habitable status of the property. This data set proved to be very challenging. The data was captured by SES staff using mobile devices. We received a fresh update of the data every day, overriding the previous day's data, and every day we had to update our web mapping and statistics we provided to management. There were many issues with this data, primarily the location and address of the points. Points captured in residential areas were not always sitting on the correct land parcel and could also be sitting in road reserves or waterways. The land address was being input manually, resulting in many misspelt road names. Also, a large number had no address attributes at all. It was important that we were able to match these points to our land parcels to provide a link to Council's property and rating system. You see the example on the slide there for Tweed Valley Way, incorrectly spelt 18 different ways. Using FME, we were able to systematically locate the points and clean up the data as best we could. We knew we couldn't solely rely on point on area overlay and that we had to clean up the address attributes to get the best match. Firstly, we assessed street names that had been manually entered in the points. Using the test filter transformer, I separated the data into 3 groups. The first group of attributes had the street number and street name in the same field. I cleaned this data up, moving the street number and street name to separate attributes, then routed the data to the second group. The second group was all data that had a street name. I used feature joiner transformer to match the street names with Council's list of street names. There were not many matches. This needed a lot of work. I used the attribute manager and set up conditional values on the street name attribute. I placed the attribute manager before the joiner so I could keep testing my results until I was getting a high number of matches. I never fixed every street name. I focused on street names in residential areas where small land parcel sizes made it harder to get an accurate matchup with point on area overlay transformer. The third group were points that had no address attributes at all. Now that the address attributes have been cleaned up, I could use the point on area overlay transformer to merge the point attributes onto council's land parcels and test that the point address and the land parcel address matched. The results were 1,215 matches from 3,935 points. The 1,215 were located accurately and had correct address attributes. Those not matched were then passed to a feature joiner to join with council's land parcels using the address attributes. Another 249 points were then matched to land parcels. Overall, that gave us 38% of points that could now be tagged as being accurately located. The remaining points were sent back to a point on overlay transformer and tagged as being not accurately located. 62% of the points were in this group, with 150 points not intersecting any land and with no address attributes. Not a great result as far as location accuracy is concerned and highlights the need for better data capture forms. This workbench provided the statistical results required for the executive management and councillors using the statistics calculator, attribute filter and feature writer to write an Excel spreadsheet. The workbench was run each morning after receiving the updated data from the EICU, and it could export a clear summary of the property status group by suburb, as well as update the mapping. The mapping and the statistics were then forwarded to council management, relevant emergency response teams, and the ADF who were on the ground assisting.
Inconsistent data formats was our next challenge. The recover system used by the roads team only extracted data as Excel sheets that were, to say the very least, very messy and not structured. They also had images embedded within the spreadsheet. We needed to extract all of the details and map the locations of damage, as well as link the images to the point of damage. Just working out how to manage the Excel spreadsheet in the format provided was a challenge in itself. How can we continually update data to crews efficiently when the data is not in a usable format? How do we extract the images out that were embedded in an Excel spreadsheet? We called on the help of OneSpatial for this one as to how we could extract those images embedded within Excel to be able to utilise them in our mapping of the locations. Luckily, word got back to the data collectors and the supply of the data in Excel was tidied up so that it was in a usable format. The images were still being embedded though. Now that the data was tidied up, we were able to use FME to create a point feature to represent the locations of the recorded damage. Mapping the locations of the damage was vital for the engineers to understand the geographic spread of damage and assist with prioritising works and planning ongoing repairs. The next challenge we were presented with was for council staff to be able to quickly get into the field to assess the damage to council's assets. The Recreation Services team needed to be able to assess more than 4,500 assets throughout the local government area to determine degree of damage. We utilised mapping we already had set up in Field Maps and Survey 123 with the locations of all assets to send crews out to complete damage assessments. All of the field data from Survey 123 was read directly into FME. Setting the parameters in the reader to include attachments meant we could bring in the associated photo with the asset. An attribute creator was used to name the photo based on the asset ID and unique identifier from Survey 123 to be able to easily link the photo to the asset. The Raster Replacer transformer was fundamental in this process. It was used to translate the ArcGIS Online attachment, which is read in as a blob, to an actual JPEG file. This has always been a challenge for us to pull images from field data and have them named accordingly and saved to the relevant directory. The Raster Replacer is now one of my go-to transformers that I use. Writing all of the inspections to Excel meant the Recreation Services team could review the data and also use this to import into Council's asset management system, and work orders could be arranged to repair the damaged assets.
We received a fresh download of the captured data every morning, and our FME workbenches enabled us to process this data quickly and push the data back out to staff and first responders. It enabled a rapid response to priority areas. It provided a clear spatial representation of damage assessments for first responders and provided comprehensive data and statistics to management in a timely manner, and made data easily accessible in a meaningful format. We continue to learn as we use FME to improve our data analysis processes. The attribute filter transformer was valuable in this project as the categories of property damage and property status were important to report against. Halfway through the first week, some of these attributes changed. Some were removed, new ones added. We didn't immediately notice this change. When we did notice, we placed a breakpoint before the attribute filter transformer with a note to refresh the attribute list. One of the things we would look to do differently next time is build in error reporting that analyzes the key attributes and notifies us when the categories have changed, so we are immediately aware of changes to the data categorization.
In the midst of a natural disaster, we work frantically to get the required information out to staff that is needed. This can mean that our workbenches might not always be neat and tidy. One thing we have learnt along the way is to have neat workbenches means any of us can open it and know exactly what is running and the outputs. So we started out with not such a tidy and functional workbench, but the end result is a clear and concise workbench that anyone can see and run as to what the outputs are.
I think the key outcome of this process is to improve the data capture. We can't rely on positional accuracy from mobile device capture. The forms that are part of the capture process need the ability to select addresses from a list. We plan to schedule a meeting with the Emergency Information Coordination Unit to hopefully work with them to build a better solution.
Although this is not the first flood we have worked through and definitely won't be the last, we can learn from this event and know that we have FME processes in place to enable us to improve our response next time. I'd like to thank you for your time today, and also thanks to One Spatial for the opportunity to present at this conference.